Ladies and gentlemen, we have come to lesson 7.1, in which we're going to learn about angle relationships in triangles. Alright, a whole bunch of little notes at the very top, and then we're going to dive into an investigation that I'm going to kind of help you through, but mostly you're going to do on your own. So, in the space up above, you're going to be taking 4 definitions. So, think about how you want to organize. You have that tiny little space. Let's do 5 definitions. In that tiny little space. Here we go. First one is the word polygon. This is a closed figure made up of line segments. A closed figure made up of line segments. You don't need to draw this example, but there's a line segment, and if I get another line segment and another line segment, and I eventually close it using line segments, I've created a
polygon.
Yay, a polygon. That was specifically a quadrilateral. Yep, way to go. Another one that you're going to note is a vertex. This is a point where 2 or more sides meet. Excellent. So, if I have 2 line segments, boom, I have created 3 vertices in this triangle. Yeah? If I do this, I still just have vertices. 1, 2, 3, 4. Okay? Interior angle. This is an angle formed on the inside of a polygon. An angle formed on the inside of a polygon. So, if you were to have a sketch, you could say here is an interior angle, interior angle, interior angle, interior angle. Okay? Exterior angle. Exterior angle. This is an angle formed on the outside, an angle formed on the outside of a polygon. But we need to continue by extending one side past the vertex. Okay, by extending one side past the vertex. So, let's take a regular-ish pentagon, and we've got 5 interior angles. And if I wanted to calculate or measure an exterior angle, I would have to extend one of the sides. Okay? And now I have an exterior angle. Okay? So on a pentagon, I can actually get more exterior angles. Okay? Here's one. Here's one. Here's one. And here's one.
Yeah, Mr. B.
Okay?
Where I thought so the top of the thing to be, would that be one?
This?
Yeah. If you
Nope.
No.
Like this angle?
No, if you went from like
No, where's the
across
top
it,
line?
what if you crossed
I
it?
could have done this,
No.
in which case this would be an exterior angle.
No. If you erase all those extra lines, you just have just your shape again, right? And the top. Isn't that one?
Interior.
No.
You mean from here to here?
Yeah.
No. So this is the rule. That's why this next point is so important. By extending one side past the vertex. So this is not an exterior angle. Okay? When we're talking about an exterior angle, you need to extend the side, and then here's your interior, here's your exterior. Notice they are, what kind of, how do I and E relate to each other? Supplementary. They add to 180. Okay? So that's one of the characteristics that we're going to be exploring a little bit today. Do you have room for one more?
Yeah.
The last one is ray. This is a part of a line with one endpoint. Okay? So a line goes forever and ever and ever and ever. So that's why when we talk about a line segment, the word segment means just a part of it. So we're taking a line, but we're actually just taking this little part of it. Now a ray is also just part of a line. It doesn't include this way to infinity. It has a one end point, and then it goes infinitely the other direction. Okay? Both of these are just parts of a line. A line segment has two endpoints. A ray has one endpoint. A line goes infinitely either direction. Thank you very much. Those are your notes for the day. Let's move on to our investigation. Here we go. We're learning about how the interior and exterior angles of a triangle are related. Okay, and we're going to be using some of the vocabulary that we just jotted down, so keep that in front of you. We're just going to follow the directions. In the space below, draw a large triangle, not your whole page, but like put it in the middle and make it pretty sizable. Make it like half, and don't try to draw one that looks like mine. Just draw whatever triangle comes to mind. Okay, it doesn't have to be any kind of regular or special triangle. I'm actually going to try to make mine not anything regular or special. Okay, we should all have different-ish triangles drawn. And once you've done that, it says to label the vertices A, B, and C. We can go ahead and do that. Step 2 says, use a protractor to measure each interior angle. Okay, so to use your protractor properly, it has that little T where the black lines meet. Okay, and you set that up right on. I'm going to start with my vertex A, and I measure that out, and I see that A is 64 degrees, really close to 65 degrees, but I'm going to say 64 degrees. And you're going to do that for all three angles. Go ahead and do that now. Again, line up your protractor, the bottom line, along with the line of your triangle. Put the T right at your vertex. And mine here is 67 degrees. And my last angle. 49 degrees. Double check that. What should your interior angles add up to?
180.
180. So keep that in mind when you're doing your last measurement. Just if it's really close to one or the other, you don't know which degree to pick the one that makes it add up to 180. Okay? Give you another couple seconds to finish that off. Everyone done? We're looking at number 3. It says, at each vertex, extend one side of the triangle to form an exterior angle. Okay, so we're using your ruler again. And the original, you can use a couple different colors if you want to. But we're going at one vertex. I'm looking at B first. And I'm going to just extend the side AB. Okay? And I'm going to go over to C. I'm going to line up my ruler nice so it's right along that original line. And I'm going to do the same thing there. And then I'm going to go up to A. And I'm going to do the exact same thing there.
What if you put your triangle right underneath the words?
Yep, that's why I recommended to go right in the middle of that empty space and draw a triangle.
Not bad.
So what we've done here is we've formed 3 exterior angles. Alright? So I'm going to use a different color. I'm going to use red for my exterior angles, but we're going to do the same activity. We're going to take our protractor and we're going to measure each of our exterior angles. Now when you're doing an investigation like this, it's okay to cheat a little bit. For instance, if you see on mine, my exterior angle measures between 131 and 132. I know that I need it to be 131 because of the supplementary angles. So that's what I'm going to use.
Can you just go 180 minus 49 because
You could, but then you'd be using a property to solve rather than an investigation. So we'll get there. This one is
And the outside measures
113.
360.
That is a great observation, Jada. And this one is 116. How are we doing on that step?
All good once we set.
Just easy.
So we have measured each exterior angle. We recorded the measurement on the diagram, and step 5 says find the sum of the exterior angles. What does that mean? So in number 5, we're taking our exterior angles. I've got 116, 131, and 113, and we're adding those guys up. Here I've got 10, carry the 1, 6, 3. Oh, what was the sum of the exterior angles? 360 degrees.
Oh, yeah.
360 degrees.
Why is mine 370?
Mine's 360. Mine's 350. Mine's 360.
Mine's
354.
370.
Anyway, again, it's a drawing, so if you're close, that's good. But that also means that you didn't follow my previous instructions on like making sure your interior angles add up to 180 and making sure all your supplementary angles add up to 180.
They all
Yeah.
added up to 180.
That
still
it
bad
for
at
sure
doing
is 360.
I was
it's not.
confused. I was
Wait,
doing it
unless you
backwards.
did
There's
mine
no
the same way.
possible way for it
I
to
was
not
like
be
this
360
sometimes.
if you did the first 2 steps correctly and copied
It
correctly.
is possible.
At any rate, doesn't matter. You all got close. It's just a drawing, so at least it shows you that it ought to be 360. Okay?
We all understand.
Good. 6. How are the interior angle and the exterior angle at each vertex related? So, look at angle A. How are the interior and exterior related? Angle B. How are they related? Angle C. How are they related?
One's obtuse and one's acute.
Okay. Let's not write that, but that is definitely true.
The lower the interior angle, like the higher the exterior.
Okay, as one gets smaller, the other one gets bigger. Nice. That's a good observation. Anything else?
180.
They add up to 180, which means they're...
Supplementary.
Everyone say supplementary.
Supplementary.
Okay, that's a word you have to remember. Excellent. They are supplementary. What does that mean?
Complementary.
Interior plus exterior equals 180. 180 degrees. Always remembering your degree symbol. All right, let's flip your page. Head over to example number 1. You've got a diagram there, and our goal is to find the measures of the exterior angles in triangle ABC. Now some of those are easy because we've been given the interior angles. So which angle would you like to tackle first?
A.
Let's do angle A. So at vertex A and at vertex B, the interior and exterior angles together form a 180 degree angle. You can see that because the interior and exterior angle together is just a straight line, which is 180. So we're looking for the measure of angle DAB. Okay? When we write an angle like that, it means we're coming from D, we're going to A, and then we're going to B, which makes A the vertex that we're looking at. Okay? So the middle letter is always the letter that is at the vertex. Now go ahead and double check on your diagram that that is actually an exterior angle. Example 1, yeah, is angle DAB an exterior angle?
Yes, sir.
Okay, so we're going for, we know this. We know that angle DAB plus angle CAB equals 180 degrees. How do we know that?
Because it's supplementary.
Yes, because the interior angle plus an exterior angle is always going to be 180 degrees in a triangle. Well, in any polygon. Well, let's do some algebra on this because I want to find out the measure of DAB. Okay? So what do I need to do to get DAB by itself?
You put CAB on the other side.
I just put it there.
Subtract.
I subtract CAB from both sides. Now I have angle DAB equals 180 degrees minus the measure of angle CAB. By the way, just a little note, this symbol right here means the measure of. Okay? So this whole thing is actually just a number. It's the measure of angle CAB. Do we know the measure of angle CAB?
Yes.
Yes.
What is it?
5 degrees.
85 degrees. So now we have DAB. The measure of DAB is equal to 180 minus 85 degrees. You can throw that in your calculator, but you should be able to do it in your head. 180 minus 85 is going to be 95 degrees. Put a box around that. That is one of your final answers. We need to find the measure of all of the exterior angles. What's the next easy angle to do? Yeah? EBC, okay? So we're going to use the same strategy. Angle EBC, which is our exterior angle, plus angle ABC is going to equal 180 degrees. What do I need to do to get EBC by itself?
Subtract ABC from one side and then put it on the 180 side.
I need to subtract it from both sides. If you do something to one side, you do the exact same thing to the other side. So get used to explaining it that way. Do I know the measure of angle ABC? 50 degrees. So angle EBC is going to equal 180 minus 50 degrees. And what is that? So EBC is 130 degrees. Put a box around that. That's one of your final answers. Have we completed the question?
Yes. Yes.
We found all the exterior angles?
But you didn't find it.
We did not find the measure of FCA or ACF. How can I do that?
You just add these two together, and if they make 360, then you're good.
So there's two methods.
You
Okay.
can add these two up and then subtract 360.
All right. Let's say method 1 is exterior angles add to 360. Okay, we'll call that method 1. So what we're saying is that this missing angle, I'm going to call it ACF, plus the other two exterior angles, which are DAB and EBC need to equal 360 degrees. Okay? Here's what I'm going to do. I already know the value of these two guys, so I'm going to group them, and I'm going to subtract that group from both sides. Okay, I realize this might be a little bit not really confusing, but I'm using the name of the angle when actually I already know the number that belongs there. Okay, so maybe in my next step what will be easier is if I replace the name with the actual value, right? Because the measure of DAB is 95 degrees, and the measure of EBC is 130 degrees. And that's going to equal 360. So now I'm going to do two steps in one. I'm going to actually add these two together because they're in a group, and I'm going to subtract that group from both sides. Okay? So we're going to be left on the left with just ACF, and that's going to equal 180 minus this group added together, 130 plus 95.
360. Not 180.
Yep, good call. There's one. So I'm going to add this group together, which is 225. I'm going to subtract that from both sides. And now we have the measure of ACF. It equals 360 minus 225, which is 135 degrees. Okay? This is one way to get that third angle. You know that the exterior angles need to add up to 360, so we just subtract the other two from 360, and here we go. Okay? Method 2 is find interior angle, then find its supplement. So that's basically get the last interior angle and then do the exact same strategy we did at the top in order to find the last exterior angle. Okay? So to find that angle ACB, what's the sum of the interior angles in a triangle?
180.
180, okay. 180 degrees minus 85 plus 50. Okay, this is my other two angles inside the triangle. I'm going to add them together and then subtract that from 180. Okay, that is going to give me that our last interior angle, so 85 plus 50 is 135. 180 minus that is 45 degrees. So this is our last interior angle. Now all I have to do is say, just like we did at the top, since ACF is exterior to ACB, then ACF is going to be 180 degrees minus the measure of ACB. And we already know that the measure of ACB is 45 degrees. So we get that the measure of angle ACF is 135 degrees. And here we have all three of our exterior angles. Again, you don't need to do it both ways, but choose the way that you like more. Okay? This method 1 was really only one major step. Exterior angles need to add to 360, and I already know my other two exterior angles. Method 2 was 2 steps, but it didn't make it harder really, because it's smaller numbers and it's something you're more familiar with, dealing with the interior angles. Okay, so you can choose which strategy you'd like to use. You'll get the same answer both ways. Example 2. Example 2 says the exterior angles of an equilateral triangle. So as we move through our unit on geometric figures, you're going to come to some special figures. An equilateral triangle is a special figure. Okay? What's special about it?
All sides are the same.
All the sides are the same, which means
If we find one angle, we know them all.
all the angles are the same. What does that mean about the exterior angles?
Means all the angles.
All the exterior angles are going to be the same. So we're going to be learning these properties and being able to describe these geometric figures based on these properties. So the question is, what is the measure of each exterior angle of an equilateral triangle? And again, there's two different ways to do it. We're going to throw just a little note in there. The note is the vocabulary term that does not look right, but we're going to write it anyway. Equiangular. Equiangular. What does that mean?
All the angles are the same.
Yeah, having all angles equal. Okay, so there's another word that we can use when we're describing our geometric figures. You have a diagram there in front of you of an equilateral triangle, and it has its sides extended already. And so there's two methods to calculate this thing. One method would be to calculate the measure of an interior angle. Okay, so method one, go interior first, then exterior. What is the interior, what's the sum of interior angles in a triangle?
180.
180. And since they're all
60.
the same, we would just say that each angle is 180 divided by 3, because there's 3 angles, which equals 60 degrees. Now,
So would all equilateral triangles have all the angles the same? Like they would always be 60 degrees?
correct. Yep, you can stretch it, you can shrink it, you can spin it, but whatever you do, an equilateral triangle will be equiangular as well.
And it would always be 60
It'll
degrees?
always be 60 because it's 180 divided by 3. Yep, no matter how big or small or stretched or whatever your triangle is, every single triangle, the interior angles add to 180, no matter what you do to it. Okay? As long as you're using 3 straight lines, you've got a triangle whose interior angles add to 180. Good. So now we've got the interior angle, and we already learned the property of exterior angles is that they are supplementary with interior. So in order to get the exterior angles, all we have to do is 180 minus 60, which is 120 degrees. Therefore, each exterior angle in an equilateral triangle, I use symbols whenever I can, each exterior angle in an equilateral triangle is 120 degrees. Alright, that was method 1. That was pretty straightforward. But you know another property of triangles, and it deals with the exterior angles. What's that?
Obtuse.
Supplementary.
What's the sum of exterior angles in a triangle?
360.
Okay? The sum of exterior angles in a triangle is 360, and we are looking for the measure of each exterior angle in this equiangular triangle. So all we really have to do is take 360, divide it by 3, giving us 120.
Done.
Therefore, and I'm just going to do a do-do, and put an arrow to my last answer. Okay? 2 different ways to get the exact same answer. Therefore, each exterior angle in an equilateral triangle is 120 degrees. Okay?
That's awesome.
If you have a little space on the bottom, just very, very quick key concepts. The sum, key concepts. The sum of the exterior angles in any triangle is 360 degrees. Okay? If you would like a little diagram, you can draw a random triangle. You can call the exterior angles A, B, C, and then tell yourself that A plus B plus C equals 360 degrees. Another property that we can gather from this, which is, maybe I'll explain as I write it. You'll need this note. Okay? The exterior, this is going to sound new, but we actually used it today. The exterior angle at each vertex of a triangle is equal. We'll copy it down and then we'll explain it. The exterior angle at each vertex of a triangle is equal to the sum of the interior angles of the other two vertices. Now, let me draw you a diagram and explain what that means. So we're looking at a triangle, and you can draw any old triangle, okay? And if I label my sides A and B and C, okay, then this exterior angle is actually the same as A plus B. Okay, and that should make sense based on the properties of triangles and angles that we know already. If the sum of interior angles, pay attention, is 180, I could find C by adding A and B and then subtracting that value from 180. Well, that's the exact same thing that's happening here. Both of these angles together add up to 180, just like the interior angles of a triangle add up to 180. So I could find C by adding up A and B and subtracting it from 180. Okay? So this is good to remember. You're going to be using this. This is one of the tools in your tool belt now as you're problem solving and finding angle measurements. The two opposite angles, the two other vertices, interior angles in a triangle, are the same as the exterior angle. Okay? Your homework is printed at the bottom. Your practice problems are from 454, numbers 20 through 32. And the worksheet on the next page you can complete right in this booklet if there is space for you to do so.